As the global installation of photovoltaic systems continues to grow, a large number of solar panels are now approaching the end of their service life. Early generation PV modules, as well as damaged and defective panels, are rapidly entering the recycling stage. At the same time, governments and recycling companies around the world are facing increasing pressure to recover valuable materials, reduce landfill waste, and comply with stricter environmental regulations. This makes solar panel recycling not only an environmental responsibility, but also a fast-growing industrial opportunity with strong long-term potential. A typical photovoltaic panel contains high-value materials such as aluminum frames, copper, glass, silicon, and plastics. If not properly recycled, these materials are wasted and may cause secondary pollution. That is why efficient, automated, and scalable recycling technologies are becoming essential for the future of the solar industry. In response to this demand, we provide a fully automatic solar panel recycling line based on a thermal and mechanical hybrid processing system designed for industrial-scale operation, high recovery efficiency, and stable long-term performance. The process starts with a robotic, automatic feeding system, which replaces manual handling and ensures continuous, safe, and stable feeding of solar panels into the recycling line. Each panel is automatically positioned and transferred, reducing labor intensity and minimizing the risk of breakage. Immediately after feeding, the panels enter the 3D scanning system, where the size of each module is precisely measured and the exact position of the junction box is identified. This intelligent scanning step allows the entire system to adapt to different panel sizes, brands, and designs without manual adjustment. Based on the scanning data, the vision recognition system accurately locates the junction box on the back of the panel and removes it automatically. This step enables the early recovery of copper cables and plastic components, while also preventing interference in the downstream thermal and mechanical processes. After that, the panels move into the automatic aluminum frame removal system, where the surrounding aluminum frames are separated cleanly and efficiently. The recovered aluminum can be directly recycled as a high-purity metal product, significantly improving the overall economic return of the recycling line. Once the frames and junction boxes are removed, the panels enter the core section of the system, the photovoltaic thermal treatment unit. Inside the heating oven, the panels are heated under controlled temperature conditions to soften and decompose the EVA encapsulation material. This thermal process is carefully designed to support material separation without uncontrolled combustion, ensuring both safety and environmental compliance. The thermal treatment plays a critical role in enabling high-quality separation of glass, silicon, and composite layers in the following steps. After heating, the panels are transferred to the delamination-type glass removal system, where the tempered glass is mechanically separated from the rest of the module. The separated glass is then sent to the glass collection and screening system, where it is collected and classified to ensure clean and consistent output for reuse or resale. The remaining composite materials, mainly consisting of silicon cells, plastics, and residual metals, are then processed by the shredding system. The shredder reduces the material into a uniform size, preparing it for further liberation of individual components. Following shredding, the material enters the grinding system, where it is finally processed to improve the degree of material separation, especially between silicon powder, plastics, and metal particles. At this stage, the ground material is fed into the air separation system. Using differences in density and aerodynamic behavior, the air separator effectively separates copper from the mixed material stream, while directing the lighter plastic materials and silicon powder together into the next separation stage. This step allows high-value copper to be recovered early in the process, while optimizing the efficiency of downstream separation equipment. Finally, the mixed stream of plastic and silicon powder enters the dedicated plastic and silicon powder separation system, where these materials are further refined and recovered individually. The result is high-purity silicon powder suitable for further processing or reuse, along with separated plastic fractions that can be recycled or used for energy recovery, depending on local market requirements. By combining intelligent automation, precise thermal treatment, and efficient mechanical separation, this solar panel recycling line achieves high recovery rates, stable operation, and strong adaptability to different types of photovoltaic modules. It represents a practical and future-oriented solution for large-scale solar panel recycling supporting both environmental sustainability and economic viability as the global solar industry continues to expand.